Back on Earth, Don Brownlee's colleagues have to slice the particles into tiny slithers before they can be chemically analyzed. Each particle is less than a tenth the thickness of a human hair. Don has discovered that the particles are rich in carbon molecules.
When you look at them in an electron microscope, it's this wonderful array of minerals and carbon and organic materials that are 4.55 billion years old, and we believe are the building blocks of life.
Huge amounts of debris left over from the creation of the solar system are still floating in space. But most of it is in the form of lumps of rock orbiting in the asteroid belt. One vital piece of evidence that supports the theory that the ingredients of life came from space is a very special meteorite picked up in Murchison, Australia in 1969.
It's a gold mine, this little chunk of meteorite which fell on Australia last year. For the past 6 months, they've been taking it apart and have discovered it contains amino acids, the building blocks of life.
This was the first time that amino acids had ever been detected in any material from space. Amino acids are carbon molecules that combine to form the proteins that are vital to all living organisms. NASA's Michael Zelensky has been researching the Murchison meteorite for 20 years. He believes that meteorites like Murchison would have been so commonplace in the early history of the Earth that they could have delivered vast quantities of amino acids from space.
Enough organics are present here that we think that meteorites like this provide to the early Earth its entire budget of organics. So all the organics in your body, all the carbon in your body, and in your lunch you had today, arrived on the Earth in carbonaceous chondrites like this. If they come in the atmosphere in large enough objects, they're like little capsules coming in the atmosphere. They break apart on the Earth's surface and deposit their cargo of organics undisturbed to the Earth.
More than 70 varieties of amino acids have been found inside meteorites, and 8 of them are the fundamental constituents of proteins found in living cells. During the Great Bombardment, throughout the early hours of the morning, billions of asteroids and comets may have seeded the Earth with the stuff of life. Compared to meteorites, comets may have delivered even greater quantities of amino acids. Some of these icy dust balls were the size of mountains, and up to a quarter of their mass could have been organic compounds. But when a giant comet struck the Earth, could these carbon compounds have withstood the immense impact?
That's good. Stop.
Jennifer Blank, a geophysicist, has designed a unique experiment to see if the amino acids could survive the trauma of impact. Using a huge gas gun, she simulates the extreme pressures and temperatures that a comet experiences when it smashes into the Earth.
We set out to test whether or not materials would survive or whether they would break down. And we expected that, or we were hoping that some fraction would survive. We figured the parts that didn't survive would break down into smaller components. But in fact, what we found was much more exciting.
In Jennifer's experiment, the gun fires a bullet at 10,000 miles an hour towards a target sample that represents the organic molecules inside a comet. The sample consists of a solution of 5 different amino acids, including glycine and proline, both present in every living cell. The mixture is then inserted into a hardened steel capsule. The impact from the gun will send a shockwave through the capsule, simulating the extremely high temperatures and pressures of a cometary impact.
I think it's very hard to just imagine what kinds of pressures were generating these experiments. If you think about going to the bottom of the ocean, the pressures you'll have there are only 100 times atmosphere. So these are hundreds of thousands of times atmospheric pressures.
Could Jennifer's experiment deliver the final proof that the building blocks of life did arrive from outer space?
Clear the room.
Using a large gas gun to simulate the colossal pressures of an impact, Jennifer Blank is about to find out whether comets could have delivered amino acids to Earth intact.
Okay, charging up. Okay, bringing up the X-rays. Okay, I'm going to external group. Ready to fire?
Go ahead.
Okay, then 3, 2, 1. 2, 1, fire.
The steel capsule was undamaged, but had its contents survived the impact. The once clear solution of amino acids had turned a tarry brown color. And when Jennifer analyzed its chemistry, she found that the material had not only withstood the colossal pressure, but it had transformed into a new compound. The energy of the impact had fused the amino acids into peptides, halfway towards building a protein.
We went from our initial small compounds, and here's an example of one of them, simple amino acid, and we used the energy associated with the impact to build larger molecules. Molecules like this. This is a peptide, and we showed that we could use the impact energy to grow larger molecules from the simplest building blocks of life.
Jennifer's experiment proves that not only can organic molecules survive an impact, but the immense pressures created can also produce complex molecules one stage closer to the origin of life. But the mystery of how and where these carbon molecules transformed into life still remains. Some scientists are now suggesting that these early carbon molecules trickle down into cracks in the Earth's crust, where the miracle of life began, protected from lethal radiation deep underground. Microbiologist James Hall has traveled from Princeton University in America to one of the deepest mines on Earth.